All right, so this is the second unit in chapter 5. And here this is the title of the section is Introduction to Solving Quadratic Equations. A couple things here. Equations implies that we're going to have an equal sign, right? Equate. So we're going to be dealing with quadratic shapes, styles that have an equal sign, and solving means we're going to find answers. So x equals what is the value, right, of the variable. This is the first video. We'll see how many this requires. I have about a 20-minute break before I need to hustle to the next session. Let's see how far we get without rushing. All right, so that's what we're going to be working on. Let's go ahead and take a look at the handout that you should have. Let's see if I have it here. All right. So first, let's start with just a warm-up of some prerequisite skills, right? Things that we're going to need that are embedded in this. So let's do a little bit of a warm-up. So why don't you try these on your own, these first 5, and see how it goes. This is a good time to pause the video and try these first 5. Just take a couple minutes, and then we'll go over them. Okay, so hopefully you had a chance to try these on your own, and now let's go over the answers. All right, so these are supposed to start off with ones that are quite a bit, are pretty basic, and then build from there. All right, so the first one, we're asked to simplify. What is the square root or radical 25 equal to? Simplify just means write it in the simplest terms possible. If you can, no fractions. If you can, without a square root, or if it has a square root, take as many perfect squares out of the square root as possible. So what I mean by that, for example, is here the square root of 25. Right, if I put that in my calculator or look at where that is on the number line, this has the same value as the number 5, right? The question that a square root is asking is, what number times itself is 25? So in this case, the answer is 5. Hopefully you know some of your perfect squares. In fact, it might be useful to write a list of perfect squares here. So see here, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, etc. 25, 36, 49, 64 is 8 times 8, 9 times 9 is 81, 100. I probably won't do all of them since it's an infinitely long list, but I'll do, let's see, I think we're usually good to 12 times 12. Let's go and go a little further. 13 and 13 is 169, 14 and 14 is 196, 15 and 15 is 225, and I'm just going to say ... Like, this list goes on forever. All right, so these are going to be useful because I know the square root of 16 is equal to the number 4. I know that the square root of 100 is equal to the number 10. So these are ones that I can, if I find these in a square root, I can write the integer, right, the number without a fraction or a decimal. So and here's a good example. In 75, this is 3 times 25, right? So let's write it as the square root of 3 and the square root of 25. Or I could have written that in the opposite order. I know the square root of 25. There's an implied multiplication here, by the way. Square root of 25 is 5. So I can rewrite this now as 5 radical 3. That's simplest terms. Notice 3 has no square root, or perfect squares rather, as factors. So that's as far as I can go. All right, 450 is going to be a little more work, but that's okay. I'll just kind of jump into it and see where it takes me. So I know this is going to be a negative value because it tells me whatever this is negative. So I'm going to go ahead and put a negative there. 450. Well, let me just take things that I know. I know that this is 45 times 10. So let me just start breaking it down that way. Okay. So those are factors that multiply to 450. Now, inside of any of these, do we see factors, things that we get that are multiplied inside to make these numbers up on our list? 10 is 5 times 2, right? So neither of those are on my list, so I'm not going to worry about that. But 45, I'll write that, 5, radical 5 times radical 2, that's 10. 45 is the square root of 9 times the square root of 5. Interesting. Okay, so now I think I've made some progress. Oh, it's still negative. Square root of 9 is 3. And 5 times 5 is 25. So these two together, radical 5 and radical 5 equal 5. And then 2 is off by itself, because none of these factors exist in a radical 2. All right, so if I wanted to simplify this, go ahead and do the last step. I'm going to multiply these integers. I have negative 15 radical 2. And I think this is the right answer. One way I can check is I can go ahead and take, let me see if I can find a calculator here. I can go ahead and take my initial problem and my answer. And I won't accept decimals as answers here, but decimals are still going to allow us to check our work. So if I take the square root of 450, and I get some decimal approximation, and I compare that to, I should have made that negative. So let's say negative 450. Same value, but negative. It's the opposite. And then I compare that to my answer, negative 15 radical 2 times radical 2. Hopefully, they are the exact same decimal. So I know that these are equivalent. Excellent. So I feel good about that now. All right, this last one. If I don't see any, I see, I guess, a 9 is in here, which is nice. But if I can, I'm always going to divide these first and see if I can get rid of the fraction piece. So 54 divided by 6 is 9. So this is the same thing as a radical 9. And a radical 9 is the same thing as 3, because 3 times 3 equals 9. So I'm going to go ahead and double check that. So let's see. Let's take the radical 54 and divide that by radical 6. 3. Awesome. So I feel good about that too. All right, so we're going to simplify radicals in the context of the problems today. So if this is a skill you don't feel comfortable with, you should practice it. I mean, it's going to be built into the problems, so you should find a way to practice it. All right, this one is a pretty straightforward two-step problem. It's solving, so we are going to get an answer with x equals something. I'm going to use opposite, right? Inverse operations to get x by itself. So first I'm going to get rid of this negative 5, and the opposite of subtracting is adding 5. So I have 2x equals 17. And now I'm going to divide both sides by 2, because the inverse operation of multiplying by 2 is dividing by 2. That idea of an inverse operation is critical in solving, and we're going to build on that a little bit later. So 17 divided by 2 is 6.5. I'm sorry, 8.5. I don't mind using the decimal here because it's an exact value, right? I didn't have to round that. That is exactly the same as 17 halves. Cool. So there's our prerequisite skills. I'll go ahead and pause it for just a minute, get situated, and then we'll start on some examples. Okay, so I've got about 10 minutes to work here, and again, I don't want to rush. The benefit of having a video is, I guess, you could always, on your own time, watch it again, pause, post a comment, things like that, to get some clarification. All right, so here, I know that something squared is 25. All right, so let's just think about what is something that if you square it, it's 25. So I imagine that a lot of you immediately said, oh, 5, right? So x is 5, because 5 times 5 is 25. So that's sort of a way to check. Right? Plugged it in. Something squared is 25. But that's not the only answer. Right? There is another number out there that when you multiply by itself, you get a positive 25. Hopefully, you're getting there. Some of you, for sure, in my experience, are already there. If I multiply a negative by itself, right, it is the same thing. So it's multiplied by itself, which is what squaring implies. And a negative times a negative is a positive. So x could also equal a negative 5. So we have two options here, two answers. And again, I can check. Plug it back in is essentially what I'm doing here. And I see that that is also the case. So our notation here with quadratics, whenever you square, you use, I guess, the inverse step here. We notice in the above example, we used adding to get rid of subtraction. We used dividing to get rid of multiplication. So if we're squaring, right, we are going to square root both sides. These are inverse operations. And the square root of 25 could be an x value that would give us 25, I should say, is either positive or a negative 5, right? So that's the notation, plus or minus, and that means there are two answers here. And that makes sense, right? Because remember the shape here, this is a U shape, and I'm asking, when does this quadratic have a height of 25? Well, if it's a U shape, there's my x squared, and I'm asking you, when does it have a height of 25? You can see visually here, there are two places where that U shape has a height of 25. And so there are two answers, right? This would be, if I were to graph this, it would look like this. Here's my y-axis. Here's my x-axis. Right? It would be up 25, but it would be over either positive 5 on the x-axis would lead us to a y of negative 5, or negative 5 on the x-axis would lead us to a height of 25. Right? So there's two options here, two x values that make this work. All right, so let's go ahead and go like more mechanical here and just what our steps are that we show when we do the work. Our general goal here, we want to isolate the squared thing. I'm going to be vague and kind of conversational on purpose. Then square root with a plus or minus notation. Okay, so we're going to isolate the square thing, and then square root both sides with, that looks like an I, but that's a plus or minus. All right. Okay, so what it looks like here is, let's get the square thing by itself. We're going to add 12 to both sides. That's our step. Now let's write the result. Nice. And now I have a squared thing by itself, so my step here is to square root both sides. And so I have x equals, this is when I add that plus or minus notation, square root of 32. All right, so that's it. That's a correct answer, 100%. But this is similar to leaving a fraction unsimplified, right? If you had 4/8, I would expect you to write 1/2. So it's the same thing here. This is a radical that can be simplified like we did in the warm-up. So are there any perfect squares built into this as factors? And so 4 is definitely there, right? This is 4 times 8. But I encourage you to look at the largest possible perfect square, right? So I usually go backwards, right? 36 isn't going to work. 25 times something isn't 32, but 16 times 2 is 32. So that's the largest one. So I'm going to go ahead and write it like this. Right? 16 times 2 is 32. Radical 16 times radical 2 is radical 32. This is a perfect square. And that was deliberate. So now I have x equals plus or minus 4. It's the same thing as radical 16 times the square root of 2. So this one is my exact answer. Okay, think of this as a fraction in that terms, right? This is exactly the answer. And then my approximation you get with your calculator. Approximations have their own value. I mean, it is useful to have approximations. So I want us to have the skill of both. How am I going to deal with this on the tripod? Sorry, I'm going to wiggle a little bit. All right, so with the calculator, I get I want 4 radical 2. Okay, so 4 times a radical 2. Approximation is 5.65, but this thousandth digit is above 5, so I'm going to round up. This is 5.66. Plus or minus 5.66. Oh, you know what? If it's an approximation, we can make that clear without me having to tell you. You can see it on the page if you do this wiggly. It means like, it's pretty much equal. Kind of equal. It's like a wiggly hand gesture, right? So here's my approximation. Here's my exact answer. All right, let's try it again. These are building, adding steps as we go. The next one, C. Let's use opposites to get the squared thing by itself. So I'm going to subtract 13 first. A lot of this mirrors your solving steps for linear, right? There are some differences, of course, but okay. So we have that. And now the squared thing is not by itself. This 4 is not squared. Only the x is squared. If this was in parentheses, yes, then the square would apply to the 4. But the squared thing is not by itself yet. Right? So we have to get rid of the 4 as well. So now I have x squared equals 240 divided by 4 is 60. Right? So I've got the squared thing isolated. Now I use the inverse operation of square roots. Square roots. So x equals always plus or minus square root of 60. I'm going to go back up here and look at my list of perfect squares. 4, anything bigger? 16 doesn't work. 25 doesn't work. 36 does not work. 9 doesn't work. So I think 4 is it. So this is the same as 4 times 15. So radical 4 and radical 15. Radical 4 is the same as 2. Let me go ahead and write it up here. So x equals plus or minus 2 radical 15. That's my exact. And then the approximate with my wiggly equals. Let's see what it is. 2 radical 15. 7.75. Again, we're rounding up because the thousandths is 5 or above. So that tells us to round up on the hundredths. So 7.75. Oh, and I forgot my plus or minus. 2 answers. There we go. All right, one more, and then I'll have you try some on your own. Again, remember the step. Isolate the square root. Isolate the square, and then use square roots as your inverse. Okay, so this one's a little different. Let's go ahead and add 11. That looks familiar. Recopy the problem. Be really careful you don't make a mistake in transposition. It's the most frustrating mistake. Now I'm going to divide both sides by 9. Still trying to get this. So I think the temptation here is to distribute. We can't. Because if I distribute, then that 9 is now squared, but it was never supposed to be squared. So remember, with solving steps, you're peeling layers off to get to the x. Okay, so divide here, rewrite. 121 divided by 9, that doesn't go in nicely, I don't think. Both divide by 3, but yeah, that's not going to work. So I'm just going to leave it as is. Oh yeah, and I think I'll be really happy with y. All right, so now even though there's a little bit more going on here, we still have a thing squared. So now that the squared thing is isolated, now is the step when I square root. And I notice both of these are perfect squares. Right, so this is the same as square root of 121 over the square root of 9. I know both of these square roots, so I'm going to rewrite it as x minus 2. I don't need the parentheses, I guess, because I got rid of the square. Equals plus or minus, always, when I square root. This is 11 thirds. Because 11 times 11 is 121. 3 times 3 is 9. Pretty good. So now my last final step, because remember the goal is still to get x by itself. Let's add 2 to both sides. All right, and what this looks like, it looks a little funny. So here x is equal to, we had a positive 2, and then we have this plus or minus 11 thirds. This is my exact answer. Added 2 to both sides, so I have a positive 2, and then I have 2 plus 11 thirds and 2 minus 11 thirds as my 2 options. So when I do my approximation, I'm going to do those as 2 separate steps. 2 plus 11 thirds, 5.67. And then x equals 2, remember, because I had the minus as well, minus 11 thirds. And that is approximately, slide this up again. All right, 2 minus 11 thirds. Let's go back to my calculator. Move it over here. 2 minus 11 thirds. negative 1.67. Now that I think of it, I could have written this as a fraction. I think I'll leave it as this. It's a good introduction. This could be simplified, right? This could be 2 plus 11 thirds is 17 thirds. And 2 minus 11 thirds would be negative 5 thirds. Right? Just it's a way of combining fractions without the plus or minus, writing it as two separate answers. Totally correct. And I bet your book has these, when you check your work, has these as the answers rather than this. This here has 2 built into it and leads us to, if we do the operations separately, these 2 answers. All right, so I'm going to pause it there. It's already been 20 minutes. Shoot, I got to go. So I'm going to go ahead and pause this now. But from your perspective, I'll be back almost instantaneously. Let's give you a couple minutes to do the try this. There's a couple problems for you to work on. See how it goes. Remember, get your exact and approximate solutions. And then I'll show you my answers, and you can check your work. All right, good luck. Do your best. Ask your partners for help if you're just totally stuck. I think just to be clear, I'm going to go ahead and start a new video on this one because I have to leave the room and take my phone with me. So I'm going to start a new video. Video 2 will start with the answer to these, and then we'll start talking about the back. So I guess it's time to load up video 2.